Hello, attendees of Microsoft Build 2022. We're here today with the Learn Live session on how to develop custom object models with data labeling tools and AutoML. You can follow along with today's session at the learning path that's going to be available at aka.ms/learn-automl. Also, you can choose to scan one of the included QR codes, and that's going to bring you into one of the two modules that we'll be covering on today's session. My name is Paul DiCarlo. I'm a principal cloud advocate out of Houston, Texas, focused on data and AI within our cloud advocacy team. And I'm joined by the amazing
Cassie Brevu. Hi, everyone. I'm super excited to be here and be talking about this awesome Learn module with you. I am a senior technical program manager on the AI frameworks team, focusing on a product called Onyx Runtime, which we will learn a little bit about today.
Excellent. And just to remind folks, today's session is brought to you by Microsoft Learn, the one-stop place where you can go to have interactive content that can teach you all about the latest technologies from Microsoft. Now, one of the cool things about today's session is that in order to get started, there's not much that you're going to need. In fact, the prerequisite that you'll need to follow along with all of the content that we will be showing today is an Azure free trial account. And that's going to give you access to popular services free for up to 12 months. And 40 services that are always free. Cool things like the ability to spin up web apps, services that will allow you to really simplify your development. And on top of that, we'll give you a $200 credit that you'll have 30 days to use that you can use on any of the available services and features provided by Microsoft Azure. Now, for today's learning path, we do require, as was sort of mentioned in the abstract, so hopefully folks saw this, completion of a prerequisite module. And this is really one of those modules where you sort of go through and create a lot of resources. So we're going to go back and recap that. But to make today's session really interesting, we're not going to start from there. We're actually going to start from the more exciting parts where we're going to start building our own custom object detection model and then putting that into training using services like AutoML within the Azure Machine Learning Studio environment. So real quick, let's go ahead and jump into the learning path, which is available at aka.ms/learn-automl. And you'll see here, we're going to start with that quick recap on the very first module. So we're going to look at what we did before jumping into today's session. So that's going to be this create workspace resources for getting started with Azure Machine Learning. Now, one of the first things that we created over here is an Azure storage account. You've probably seen one of these before. I'm going to go ahead and jump right into my Azure subscription and jump into my resources, which I've already got organized on my dashboard. And we'll click into that to sort of show you what's going on and like why we're using that, because it's like totally relevant. Cassie will explain all of that to you in just a moment. So we're going to use something called a container. And inside of that, we're going to start storing our untagged image data. Cassie, what does that mean when we say untagged image data?
That means we haven't labeled it yet. So we have all of this data that we need to be able to label so that we were able to create a model, since we're doing something called supervised machine learning. And with supervised machine learning, you need to tell it what it actually is. So by labeling it and letting it know what's in the image, that's how we're able to train it and it's able to learn.
This is cool. Like, I'm just going through here. I'm sure people saw, like I was clicking through as you were mentioning that. This is one of the images that we're going to be using. And this is familiar, right? Some soda cans. That's because today's example that we're going to be walking through is sort of talking through a scenario where you're wanting to automate like a manufacturing facility line where you've got, perhaps products coming down. You want to be able to detect, what those items are, count them, maybe look at defects that could be coming off that line. And well, to do that, we need pictures of the thing we want to find. So why not put that in Azure storage in the cloud, get infinite scalability and that ability to just use it. But that's like part of the picture, right? Because we're going to do something with this data. Now, here's the cool part. We marry that up with something we call an Azure Machine Learning Workspace. So I'm actually going to jump into here to my Azure Machine Learning Workspace resource. And once we do that, you'll see here, I'm sort of presented here with an overview pane in this section here that says Studio Web URL. This is one of many ways that we'll be talking about today where you can sort of go back and forth to your Azure Machine Learning Studio instance, the thing that really is going to do all the magic for us in the ML/AI space for today's session. Now, once we're inside here, we're going to go ahead and look at creating a few things that are going to really help facilitate today's tasks, which are training that model. And the first thing we're going to do is use something called a compute instance. So when I go into here and we click on compute, this is pretty cool. You can maybe guess what this is when you look at it, but Cassie, I'm going to let you explain, like, what are we doing here with this compute instance and why is it awesome?
Yeah, so Azure Compute instances come pre-configured for machine learning, which is really cool. So if you've ever done any machine learning locally on your own desktop, you know that there's a lot of configuration and things you need to install and set up. If you want to use your GPU, you have to set up things like CUDA if you have an NVIDIA GPU, and different execution providers, as well as the different tooling, your Python environments with all the different tools that you need for data science. So with Azure Compute instances, you can create a compute instance, and it actually comes pre-configured to do data science with all of the tools that you need. And then you can also customize those experiences as well as share them with other data scientists on your team. So it creates this really neat shared resource that's ready to go. And then you can use, the power of the cloud. You may not have a super powerful GPU on your desktop, and most likely you don't have enough on your desktop to run some deep learning models once you get into very large models and lots of data. And so you can leverage the power of the cloud. And so that's what these compute instances really do for you.
And I love that. I like how you said that. Like, there's the chip shortage currently, and maybe you need to get a GPU, and they're like not available at the store. Just go to the cloud and spin one up, right? Hopefully there's one available there, right? We want to make sure those are there, but they should be. And that's the cool thing. So the next thing we're going to look at is after we create that compute instance, which is going to have all those development tools and really be the compute power that does the training for us, we're going to look at creating a data store. And so this is an interesting concept here, because remember what we showed you earlier, right? We store data in Azure Storage. To marry that up to Azure Machine Learning Studio, we can create something called a data store. And I'm just going to really quickly show what this process looks like for creating this. And you'll notice a lot of the resources in Azure are already available here. So for example, if I want to use an Azure file share, or maybe Azure Data Lake Storage Gen 1 or Gen 2, or SQL database, PostgreSQL, or MySQL, those are all valid candidates to use as a data store, which is awesome because those are secure resources in Microsoft Azure. So your data is secure, and you're now able to service it into this application where you can then work with it. So as long as I've already got my subscription ID attached here, and I've said what kind I want, in this case, we're going to use a storage container, I can choose that storage account. And from there, it's already going to know the containers that are associated with it, which we showed just a moment ago, that image data container that we were just exploring a moment ago. We marry that up, give it an account key or an SAS token, and now that data is securely served up into our Machine Learning Studio instance. That easy. So now that we've sort of showed where we can get started putting our data together and building an Azure Machine Learning Studio workspace, we've sort of showed what the resources are that we're going to be working with today. And that kind of concludes the whole prerequisite section, if you will. And now we're ready to jump into our first module for today's session. So you'll want to go ahead, if you're following along, you can head back over to that learning path at aka.ms/learn-AutoML. And we're going to go over to the create a labeled data set using Azure Machine Learning data labeling tools. If you want, you can find it on the learning path itself or scan the QR code in the bottom left of the screen, and that will bring you directly to that module. So just as I said, we're going to go ahead and start exploring this. We'll jump into create a labeled data set using Azure Machine Learning data labeling tools. And this is fun. We're going to learn some cool stuff. Going through just the objectives here, I'm excited. We're going to create a data set of labeled images that will retrieve from our attached data store, that Azure Blob Storage we saw earlier. We're going to coordinate data labeling and using team members in a parallel fashion to manage the task of processing our labels for our images. Then we're going to track that progress, and we'll maintain a queue of all of our incomplete labeling tasks. And finally, we'll be able to review that labeled data and export it as an Azure Machine Learning data set. So I think we're all excited. I hope you're all as excited as I am, because we're going to jump in. And it's funny, as many times as we do this, I'm always excited. Like, I cannot wait to show this tool up. So what's it going to look like? You can see here, we're going to label some images. We're going to find inside of those images of our soda cans, we're going to label those appropriately. And you can sort of see what this is going to look like. We've got a tool that'll allow you to draw polygons or bounding boxes around the objects of interest. And that's the magic of turning untagged data that we surface from a secure data store into tagged data, which means it's a candidate for training for a custom object detection model. Very cool. So imagine this scenario. You're a data scientist. You've been assigned the task of improving automation in a manufacturing facility using computer vision. And you've chosen Azure Machine Learning Studio as the development environment. This is great because like you can divide up tasks. Like Cassie, I think you were telling me we can use role-based access controls so that only the people who need to see things will get access to those things.
That's absolutely right. Because sometimes the data labeling process is a very lengthy one. And sometimes I feel like, getting your data ready and preparing it for training is just one of the hardest parts because you can have a lot of data. And so sometimes you might want to hire a vendor or outsource some of that. And that's where being able to control what people can see in your resource, in your Azure Machine Learning resource, can be important.
That's awesome. And so like we've already done the hard part, which we showed earlier in the prerequisite, which is like making that data securely available. And I thought that was easy. This is why Azure Machine Learning Studio is cool, because getting that data surfaced in a secure fashion was not that hard. So to follow along here, we're going to have those things like side by side. We're obviously going to be working in Azure Machine Learning Studio. So I'm going to go ahead and configure my setup here real quick so that I've got one of those resources over here on the right and then one of them over here on the left. And we're going to really quickly go through these steps. We'll sort of scroll through them. I might not follow them one to one, but the same things are going to be sort of mentioned here. So folks who are following along at home, if you do what we do, you're going to end up with the same result. And that's the awesome thing about Learn Live, is that if you love this session, you can always go back here to the learning path and use it again, if you want to learn more, or share this with others, present this at a user group, present this at your school, whatever. It's absolutely amazing. And that is the cool thing about MS Learn, learning at your leisure. So what we're going to do is jump back into our Azure Machine Learning Studio instance. So I'm actually going to go back into here, and I'll start from the home page. A few ways to get here. You could go to the resource in Azure and click on that Studio web URL. There's also a cool way where if you just go to ml.azure.com, which is highlighted here, that'll just literally bring you there. And then if you have multiple instances, you can choose the one that you'd like to work with. Next, what we're going to do is scroll down to the bottom on the left-hand side where data labeling is. And if you've never created a data labeling project, it will ask you to click the Create button. We've done that, so we're going to click Add Project here. And what I'm going to do here is quickly give this a name. So we'll call this Soda Labeling Build Demo. And we're going to choose the media type. Now, this is interesting. All we've talked about so far is computer vision, but we can also label text-based projects. And that seems interesting. Cassie, why would we want to do that? Like, why is that awesome?
Yeah, absolutely. So obviously, there's pre-built models that we can use for different text processes, but a lot of times in different industries, there's a lot of jargon and things that are specific to the named entity recognition models or all these different things that you need to understand your jargon in your business. Even might be specific to your company. So if you can go in and you can train natural language modeling models that understand your business and your language and your jargon.
That's absolutely amazing. And so I guess that's where you can start to drive things like voice assistants, auto translators, things like that, chat bots, I'm sure. All of that's driven through text that's trained similar to the way that we're going to work today with image data. And in our case, we're going to go with object detection or identification using a bounding box. So this will be able to tell us, like, this is a thing, whatever that happens to be, hot dog, not hot dog. And this is the area within the picture that it is. So we're going to draw that bounding box around that, give you those coordinates, and that opens up a whole slew of possibilities, fixing the manufacturing line, if you want to stock shelves, all sort of things. Oh, wow, this name is already taken. Well, you know what? We're going to do the old trick that we always do, called V2. I like that. So we'll go ahead and validate that. Now, this is awesome. This second option here, which is totally optional, is if we want to add a vendor labeling company from the Azure Marketplace here, you can turn that on and then just choose here any of the available vendors, and they'll have resources, like literally human beings, that can go through your data and label it for you. Now that sounds really cool, Cassie. Like, I know you've worked with a lot of startups. Like, why would this be something cool? I mean, it's a little obvious, but give us, like, you've seen this. You've seen like small companies literally turn the key and now they're labeling.
Right. Yeah. So we talked a little bit about the fact that like we give these options for it within AML, but there's also like full startups that are just around data wrangling, like getting data prepared for processing. Because the thing is there's so much data that we have, and getting it prepared for supervised models is no small task. And so any way that you can get help, and a lot of the things that we have within AML, there are little like startups around one piece of this, solving just that one problem. So AML brings all of these pieces together, which I think
that's absolutely fascinating. So just folks that are wanting to start building that new AI experience, like, you can do that, and you're now enabled just with checking a box, essentially. We're not going to use that today, but obviously that's too cool not to mention. So next, what we're going to do is go ahead and bring in our data. So this is, as you might expect. Remember earlier, we created that secure data store. So what we can do here, we can select to create that data. We can either, upload that directly using local files, or go into the from data store option. And this is what that would look like. I've already created one beforehand that we know is going to work, that attaches to the one we created in the prerequisite. But just to walk you through these steps, if we did want to create this, it's really straightforward. Give it a name, then you can choose the existing data store. So this is going to point to our Azure Blob storage with our untagged data. We give it a path, and the easy way to do this is provide a slash here, and that will give us access to all of the data within that subdirectory. And then from there, if we want to validate our data, you can just leave this unchecked. And then we can skip forward and basically click create, and we now are able to surface that to our data labeling project. Now, that's all I would have to do. So I'm just going to cancel out of this. But we've already done the exact same thing here. So I'm going to select that existing data store and move on. But this is exactly the steps that you would follow along at home for folks who are using their data. And this calls out something really interesting too. While we're using this sample data in this project, if you wanted to use your own data, there's nothing about that data that's special. Like, let's say you don't want to detect cans, you want to detect puppies and cats. Give us some data like that and start, labeling it as such, and we'll show you exactly what that's going to look like in a second. You're off to the races. So the next option kind of seems like one that you would always want to turn on, but I guess it depends, which is enable incremental refresh. And what this does is, like it sounds, as more data comes into that data store, it will check that at intervals and basically surface that to the data labeling project, which is awesome. And so what we're going to do here, we'll enable that, go forward. And next, what I'm going to do is go ahead and provide the names of the classes or objects of interest that we're going to find in our data. So we know these are cans. So I'm going to go ahead and provide the label, which would be Coke, Diet Coke, and also Sprite is going to be in there. Really straightforward. Then I'm going to go ahead next. And we're now at the section where we can provide labeling instructions to our reviewers. This is cool. If you have a URL, you can point that here. All this means is that when someone gets this data and they're ready to start labeling it, you can tell them yo, some of these images, you might want to look on the far right and get the halfway can that you can barely see because it's there. Anything that happens to be, or maybe Cassie, I'm sure there's a million reasons why you do this. Some of these images might be taken at night. Please don't forget to label those, right? Whatever it happens to be. So that's a pretty straightforward one that will just, if you do have a need for that, you can provide those instructions there. And then we're going to talk about something really cool, and that is the ability to enable ML assisted labeling. Now, what this is really interesting. After you've labeled approximately 300 images in your data labeling project, ML Studio will go ahead and create a model that will just automatically start labeling those objects in your image data without you doing anything. So it's like an inception thing. Literally it becomes so smart. You start building the model, it starts basically using the model to label the new data that it's never seen before.
So cool.
And then you as a person can like manually validate that, which we call human in the loop labeling. So this is like super cool. And to do it, you just like slide the slider to the right. Now we're not going to do that here, but just for folks out there who do want to try this, 300 images approximately. Once you're there, it will start doing that magic for you. So we've done this. We've got everything created here. We're now ready to create that project and move on to the next unit in the module. Super exciting. So in just a moment, that is going to spin up the project, SOTA labeling build demo v2. And once that's done, which that didn't take very long, we're going to go ahead and click into that. And now what we can do is click on the label data section here in the upper right, and we're off to the races. We're now ready to start working with our unlabeled data and do the magical task of translating that into labeled data, or transforming, I should say. So I'm going to go ahead and blow up the screen here so we can see a little bit more and choose those objects of interest and just show you like we can just go in here and start drawing bounding boxes around this. Now, if that is too boring for you and you want to like be like seriously keyboard commando, here you go. Keyboard short keys that will allow you to very quickly cycle through. You know, like you could be like those, you know, those people are just so good at Vim that like watching them is like watching like a great composer from the from I don't know, like it's like fascinating to watch you can do that here. Now I'm not that.
Oh, sorry, what?
Yeah, I'm not that good. I'm not. Yeah, I'm not the Bach level labeler of data science. But with that said, Cassie's going to tell us all about, you know, what's important, some things to just like pay attention to as we're labeling, and give you guys some background on like, you know, what some of this data preparation tasks, some things to just note and be aware of.
Yeah. Oh, but on the shortcuts, I come from a .NET background, and Visual Studio, like using the shortcuts in that, like you can get so much more productive. So I'm all about the shortcuts, and I love that they've added them into this product. But here we are labeling by dragging and dropping. And so one of the things you'll notice as he's going through these images is there's a lot of different types of images here, and different lighting, different backgrounds. And the thing is we need to add kind of that noise to the data set in order for the model to better learn and understand our data. The other thing is that we are going to have to label at least 10 images here, as that's a requirement of AML. And that's because we want to have more data, but also 10 images, if you built computer vision model probably doesn't sound like that many. And that's because we're using something called transfer learning, where we're able to use a base model and then train additional layers on. So we're able to get actually pretty good results with 10 images, which is amazing. So yeah, as we go through, we want to make sure that you get different angles. Like if you're looking at how the sprite is not always forward. And the thing is when the model understands or like learns this data, think of it as like memorizing your data. And if you only ever show it one angle of the can, it's only going to know that one angle of the can. So if you think of it like that way, it kind of helps you start to understand how you need to start taking those images and start getting your diverse data set.
Now, and I would imagine too, Cassie, that like 10 images, which is cool because like for folks following along today, like, you know, we don't have to stop here and park here all day labeling images. That's cool. But also I would just imagine more data is going to equal probably more precision or quality in that resulting model. And like, what are we talking about here? Like folks that are really putting these into production, like what kind of data sets are we looking at here? How many labels should we go with if we want something that like works, you know, really well, state of the art?
That really depends on the problem. You know, you do want to have enough data. You also want to have enough good data, because if you have bad data, you can add model confusion. And so there is kind of this thing where it's like always more data is better, but more data is only better if the data is good. So, and then also like with that monitoring that we saw earlier, where as you're getting more images in and you're able to start labeling new data and getting that in, like that kind of automates your MLOps process. Like you already are adding in data pipeline things that are hard to solve without these tools, including versioning. You know, there's versioning in here as well. So there's a lot of things that are making you follow good ops processes and then building it into it. So making it really accessible and really democratizing the process.
That's rad. So I think we're almost done here. If you did want to check, like to make sure that you have 10, you can click on the name of the project here, and that'll back you out and tell you, like in our case, 10 out of 242 have been labeled, which is awesome because we only need 10. That's that minimum that we sort of need for Azure ML Studio to submit a object detection training task. And so once we've gone ahead and done that, we're now ready to export our work. And we're going to export that into something called an AML learning data set. And just like Cassie was mentioning, this is awesome because while it's going to seem like this is a simple thing, we're literally just going to click export Azure ML data set. But the cool thing is, like, if I want to include the metadata here, like who was a labeler? It was me. All right, I did it. We know who did it now. And we can tell the date. But the more important thing was a word that you mentioned over here, Cassie, which was versioning. So if I click on the data set that was just exported, there's a number of ways to do that, but you can just click right then and there. We can see inside of here what's going on, but you'll notice here too that version tag. Like I see, okay, well, here's the labels. We can review it, right? We can make sure the labeler is doing the right job. But where does this become important in that whole life cycle of ML ops?
Well, so there's things called data drift, right? Or data gets stale, or your model gets stale. And as everything changes and your data changes, your model that may have been performing really well originally may not be performing as well a couple months later or 3 months later, depending on the type of problem you're solving. So understanding that you can add new data and retrain, but then also sometimes you might add new data, retrain, and for some reason you might be getting a worse result. Like maybe you added some model confusion because there was some bad data in the latest train. Well, this allows you to know that I can go back to my previous model or my previous version of data and retrain like that. So being able to version both your data and your model becomes extremely important, just like you version your code.
Awesome. Yeah. I love the way you said it. Just like we version our code, right? We all are versioning our code.
Yep. Because we're creating code with data. Like really, a model just memorizes the data and creates a function with data. And so it's got to think of it just like you would think about the code that you write. It's just writing it for you.
Expert advice there. All right. So now that we're becoming experts, we're going to check that with a knowledge check. So definitely listen up here because we want to make sure everybody's following along, that what we're saying is starting to make sense. And also a few questions here. I think we're really just going to test whether you're paying attention. So in this module, our image data was referenced using a data store that was attached to an existing Azure Blob Storage in an Azure Storage account, Azure Synapse Analytics data pipeline, or a file share in an Azure Storage account. This is one of those were you paying attention questions, I think. Now, while there was, of course, multiple ways to do this, we have been using that Azure Blob Storage with the container that has our raw, unlabeled data that we're now transforming into labeled data. Awesome. Our next question, ML-assisted labeling was not required in this module, but how might that be beneficial to a data labeling project? The first one is ML-assisted labeling creates a model that can pre-label data in new image samples that may be reviewed later by teams for accuracy. That sounds familiar. But let's look at the other options here. ML-assisted labeling can determine objects in an image using an existing model that detects a variety of common objects. It seems legit. We were talking about transfer learning. Cassie had mentioned that could be possible. And also allows you to submit unlabeled data to a third-party service that employs human labelers. We did say something about that. But in the context of this question, of course, I believe that it is the first one. This is that where you upload 300 images, or I'm sorry, label approximately 300 images, and Azure ML Studio will make a model that labels your model using the same model that your model uses to know what things are in what places. It's the inception of AI, creating AI to create AI.
I love adding machine learning into my machine learning. Like just automate all of the things because we're all lazy developers as it comes around, so we just want it to do it for us.
And what is AI but computers doing things for us? I love it.
Yeah. So
the reason we labeled 10 images in our data set was to satisfy the following requirement. 10 is the total number of images that make up our data set. That's sus. That is a sus response there. 10 is the maximum number of images that can be used to train an object detection model. That seems sus as well. So I hope this last one's not sus, otherwise we don't know what the answer is going to be. It's Azure ML Studio object detection experiments require a minimum of 10 labeled samples in order to successfully train our object detection model. This is like one of those questions you get on a final exam and you're like, the professor definitely wants you to pass. So yes, it is the third choice there. We'll go ahead and check our answers. And hopefully everybody's moving along. You've got the badge. You're ready to continue on to the next module. And that's going to be even more exciting because check this out. We're going to talk about using AutoML to train a labeled data set and develop a production model. And if for those of you following along, you know that this presentation only lasts 1 hour. And we've only got 30 minutes to show you all of that. And we're going to do it. And you can follow along too at aka.ms/learn-automl. So we're going to head back to our learning module. And from here, we're going to navigate to the third module in this collection of the learning path. And that is the use AutoML to train a labeled data set and develop a production model. So we'll go ahead and click into there and cover the learning objectives, which again, just as exciting as last time, if not more. We're going to look at authoring AutoML models for vision tasks using the Azure ML Python SDK. So Python is going to make an appearance. That's going to be fun. We'll seamlessly integrate with Azure Machine Learning's data labeling capabilities. So everything we just did is going to become relevant here. We're going to use that data to optimize model performance by specifying a model algorithm and tuning the hyperparameters using AutoML. We'll then operationalize at scale using Azure Machine Learning's Azure ML or MLOps capabilities. And finally, download the resulting created module from all of this work for use in a production environment. Now, this is cool because what this is going to use is something called AutoML, which is one of those Microsoft product offerings that makes your life easier. Like that's its whole reason for existence. Like a lot of the stuff we create here, it is one of those things that just takes out the guesswork. So Cassie, like when we're building models behind the scenes, there's all this stuff going on where you're creating a convolutional neural network that has all these nodes. It has weights and decisions that it makes.
Yeah.
And like AutoML, like figures out the best way to do that?
Yeah. So behind the scenes, I think it's using something called Hyperdrive, which is an open source product that actually tries different hyperparameters. So different like learning rates and different amount of layers or epochs. And it goes through and tries different things to see what is the best result model I can get. And it'll go through and basically tune that model for you and then choose the best one that will work. And then it's using, obviously, like you said, a convolutional neural network. So it automatically creates a model for you and finds the best one, which in data science, we called it the loop of sadness, where you'd have to go through and try all the different hyperparameters till you get the best results for the best amount of training epochs.
The loop of sadness, or hyperparameter sweeping, is what we're going to call it with AutoML, right? Which is that's just cooler.
Because you don't have to be sad when they do it for you. That's
lovely, lovely. So get happy, learn about AutoML. We're going to talk all about that here. And again, we're going to return to that scenario, the same scenario we've been talking about this entire learning path, where you're that data scientist, you've been assigned that task of improving automation in a manufacturing facility, and you're going to do this using the latest and greatest computer vision. And how we're going to do this time is we're going to investigate building a model, but not just any model. We want to use Azure Machine Learning Studio with Python and use that Azure ML Python SDK to create an Onyx-based model. So, Cassie, this is like the amazing part here. Onyx is interesting because, well, I'll let you tell us.
Yeah, so Onyx it stands for Open Neural Network Exchange, and it's a way to convert your model into a file format that makes it able to be used in multiple different ways. And so once you convert it to an Onyx format, you can use something called Onyx Runtime. So Onyx Runtime optimizes the performance of your model, so you're getting the most out of the GPUs and CPUs that you're using, but it also allows you to deploy to multiple platforms, as well as inference in multiple languages. So it gives you a lot of tools, and it makes your model really useful, because many times when you're training, your model usually in Python, or maybe you're using AutoML, and then you go to inference and you're not necessarily using the same tooling that you did to make it. You're not maybe in Python, like maybe you are going to inference in C#, and maybe you want to inference in mobile or on the web using Onyx Runtime Web. So it actually gives you all of these abilities to deploy your model everywhere. And then also, if you're into Onyx Runtime, or if you're already using it, or if you're just curious about it, we do have an Onyx Community Day coming up at the Microsoft Silicon Valley office, brand new office, virtual or in-person attendance. So check it out, and I'll be there, and I hope to see you there.
That's amazing. Yes, and we've got that link up on the screen, so definitely check that out. Learn more about Onyx and why it's amazing and awesome. And you know what I love too about this module? We're going to not only be doing all the awesome stuff we've already said, we're going to use that compute instance. From there, we're going to build all this in a Jupyter notebook, and that's going to let us like loop all the way around to where new data comes in, incrementally refreshes, run the steps in the notebook, build the model in Onyx, and be able to retrain essentially at will and deploy to anything that can run and perform inference on an Onyx model. So if it's got a GPU there, it'll leverage that. If it's got an FPGA there, theoretically could leverage that. CPU bound still works anywhere Onyx runs, which is awesome. So we're going to go ahead and continue now into the Jupyter Notebook workspace. And again, I'm going to set up the screen so that it's easier to follow by having this side by side with our module as we go through this. And the first thing we're going to do is head back to our Azure Machine Learning Studio workspace resource in Microsoft Azure. Now, the reason we're doing this is because inside of the resource page is a little section here that says download config.json. We're going to go ahead and click on that. Now, this is interesting because config.json is basically the keys to the kingdom. And when I say that, I mean, this is going to allow us to use that Azure ML Python SDK and authenticate against our instance broker commands to create things like tasks, training activities, and that sort of stuff. Really put that data to work using all those resources, your things like your compute instance, etc. Super awesome. So we'll go ahead and navigate back there. Again, you could also get there by going to ml.azure.com and find your workspace. And once we're there, we're going to click into our compute instance section. And this is going to bring us to the pre-configured machine that Cassie showed us earlier. And we're going to click on the Jupyter link here. We'll go ahead and open that in a new tab. And now, because that machine came pre-configured, we're literally in the Jupyter workspace. We can navigate into our user directory. We'll go to PD Carlo here. You would use your own username. And you'll notice here, I've already got config.json loaded here because I don't want to mess up this demo is why. But the first thing folks at home will do is you'll go back, find your own config.json, and you will upload this using the easy upload button here. Select that config.json file and get that into your workspace. Next, what I'm going to do is download the Jupyter workspace files. Now, this is a collection of files coming down from GitHub. So I'll go ahead and download that. And I've already extracted this folder, but just to let you know, the goodies that are inside here include things like we've got our Python notebook, which we'll be working with shortly, a test image. So this is an image that our object detection model will have never seen. So we'll be able to tell, like, does it really detect things? Because, like, it's never seen this image. So what does it think is in the image? And that's going to give us some validation that it, in fact, works. And then we've also got a Python script here that will pre-process and train our model and convert it into the format of Onyx. So this is a helper script that will help us work with that Onyx format. So once we've got all these files set up here, we're going to go ahead and upload those as well into our workspace. So you will want to make sure that you've extracted those somewhere on your machine, select them, choose open, and then we can click one by one on here to truly upload those into our workspace. And that's pretty much all we're going to need in order to have the things we need to work through the next unit in this Learn module. So the final resulting result should look something like this. You'll see mine are looking exactly the same. So we're now ready to proceed. So next, what we're going to do is jump into the notebook. So we'll go ahead and select that. That's going to launch us into a Python notebook instance where, and if you've never seen a Jupyter notebook, these are so awesome. It's like a place to run Python code interactively. And it's the coolest way to learn because, like, you can change what's in the notebook and get the results. You see things in the notebook. Like, this is how programming should have been. Do all the things in the notebook. So when you open this, just a quick word of caution, you might get a message that says kernel not found. And that would probably freak you out, you know, kernel panic, basically. If you do get that, we're going to go ahead and choose. You should get some options here. You'll want to select Python 3.8-Azure ML from the dropdown if you get that. We're not getting that because we've opened this before and we've already selected that over here on the left. But just for folks at home following, if you see that, don't panic. It's not a kernel panic. It just means you haven't configured your environment. So just select the appropriate one. Happy times. Next, what we're going to do is go through the environment setup. And I'm going to do this in a way where I'm kind of skip ahead. Because like you ever watch those cooking shows? We're about to bake a cake and it's going to take like 7 minutes. So we want to start, throwing that in the oven now. So I'm going to go ahead, Shift Enter. Inside of any of these cells will actually execute that code live. And I'm going to just sort of go through here very, very quickly, go through until the part where we submit this to training. But don't worry, I'm going to go back and explain all this. This is just magic here for the sake of demonstration. Folks at home, you do not need to do what I just did. But if you do want to follow along and demo this, perhaps, at a user group or something like that, I definitely recommend sort of jumping ahead here. So now if we look over here on the right side, we're going to go through and look at what those commands did just now. So the first thing was installing the Azure ML Python SDK, which, as you might think, is going to give us that library within Python that's going to allow us to reference Azure Machine Learning Studio. Next, what we're going to do is run this block of code underneath here that's going to validate to us whether we're running an appropriate version of the SDK. So this was created using version 1.35. We're now using version 1.39, which is greater than or equal. So that kind of tells us this is cool. If you were using a version under, this block of code would tell you and be like, hey, upgrade your Azure ML. Then we're bringing in Torch Vision, which is interesting. Cassie, I know this is like a really popular library, and there's quite a few distributions of this. Why would we be using Torch Vision, and what's the cool thing about that in the data science community?
Yeah, so when you're making deep learning models, generally you're using TensorFlow or PyTorch. So in this example, we're using PyTorch, and then within PyTorch, they have different libraries that are available specific to the type of model you're building. So since we're doing a computer vision model, we're going to be using Torch Vision. There's also Torch Text for NLP, and also Torch Audio for audio classification and audio tasks. So we want to make sure that we have PyTorch and PyTorch computer vision package ready.
Excellent. And I'm noticing here too, we have one of those points like, again, after you install this particular package, it does do some modifications to the underlying kernel. So you will want to select Kernel Restart. We don't need to do that here because we've already done that a few times, but just note that that is a step. We try to call that out in bold in the Jupyter notebook here. So if you are following along, do make sure that you've done that, and then you can proceed exactly at the point where you had concluded earlier. And this is a great part, actually. We're going to run pip freeze here, which will show us all of the installed Python packages that we have in our whole Python environment. So you should see here a few things like that are going to be preceded with Azure, likely that are coming down as packages with the Azure ML SDK, the Python SDK that we installed earlier at the very start of this. And then underneath this, you will see the libraries that we're going to sort of make common reference to. Many data scientists out here probably recognize these. Cassie, you definitely see these all the time. What about for us, folks that are maybe new to this? Why would we be using these particular libraries here?
Yeah, so we have CV2, which is Opencv, which is a very popular open source library that allows you to do common computer vision tasks on your data. So you have to do different transformations and prepare it for processing. And so Opencv is a good way to do that. NumPy is a numerics library, which you need for machine learning processes. And then Torch is PyTorch. And then we already talked about Torch Vision, and I think the other ones are kind of self-explanatory there. So we're going to need all of these libraries in order to build our computer vision model, and are very commonly used.
So after we brought those in, now it's going to sort of make sense. We're going to bring this like full circle and basically start connecting to the Azure Machine Learning Studio workspace. And from there, we'll be actually submitting this to operate on our data and train that custom object detection model. So the first thing we'll do, and this is coming from that Azure ML Python SDK, we'll bring in the Workspace package. And from here, we call Workspace from config, which will look into the current working directory. And if it sees the presence of a config.json file, we'll then leverage that to use it to broker against our Azure Machine Learning workspace, like basically authenticate against it. So you'll see I'm now authenticated against the resource that we created earlier. And we've got a successful message indicating that there was no issues in using that configuration. Next, we're going to go to the compute target setup. And this is interesting because this is the part where we're going to use that compute instance that we created in the cloud, set that up as a target for submitting this data workload to for processing. And I want to point out a few things here. We do need to provide a compute name here. And I would highly suggest, and you'll see this written in the module, that you use the name of the compute instance that you created within Azure Machine Learning Studio. So mine was called Image Processing Instance. If you reuse that name, the same machine that we're using right now to run this Jupyter notebook will be the same machine that actually runs the job that we're going to submit to it for training. If you put another name here and it's unique, see, if it isn't unique, you might get a collision and it just won't spin up that machine. It'll say somebody's already using that name. But if you put another name here and it's not reusing the same one, you're going to spin up 2 VMs. And while this code sample will work, you're going to be using 2 VMs when all you need is 1. So definitely pay attention here to that compute name parameter. And once you've done this, we're going to continue into the experiment setup cells. These are interesting because as soon as we run this block of code, this is going to do that first thing where it's going to create something in our Azure Machine Learning Studio workspace. And so in this case, if we go to jobs, you'll see it's created a new experiment called AutoML Image Object Detection Latest v3. And that is the result of running cell 9. Once you've got that set up, we're then going to start importing data from our data set. Because remember, we did make that securely accessible by creating a Datastore earlier. We're going to go ahead and get that by name. So you'll notice there's a parameter here, name. The way that that name is retrieved is if we go to the particular data that we created earlier, we can literally choose that name. Now, earlier, we created a set that had 10 labeled images. I'm going to choose this one because it's got 50 labeled images. And that's going to give us a better quality model. So while I didn't have to take the time to train that in front of everyone, I'm going to use that here. And that's exactly where I got that name from. You'll see here under my registered data sets, we choose SOTA, the middle one here, and provide that as the name parameter. Once we've done that, we can then pass this off to Pandas, which is going to convert this to a data frame. And this is really a block of code that more than anything is going to validate that your data is absolutely coming from that Azure ML data store. And you'll see the results here where it sort of mentions, the labels that are present there, the image height and width, etc. And if you get this result, you are now ready to start training the object detection model. So this is absolutely amazing. We're like literally at the point of creating our own thing here. And this could be with any data. So, of course, the whole point of today's session is learning about AutoML. And the funny thing about this, like I said, this is one of those Microsoft products that does like all the work for you. It's this block of code in cell 12 where we create an AutoML image configuration. We specify this to use the YOLO v5 object detection algorithm and give it iterations of 1. Now, if we gave this more iterations, it'll actually train it more and more times. But this is all we need for demonstration purposes to perform that hyperparameter sweeping process. So we submit this as the type of configuration that we want, and then push that to our experiment that we created earlier. And this starts the remote run that lets that job complete. And this performs the actual training itself. So it's really awesome to look at that, where simply using an SDK, we specify the type of training we want to do, and we're then able to push that into our experiment and run that within our compute instance. So if you're following along, this is that part where it might take a few minutes for this to complete. You can monitor this if you do head on over to your experiments or jobs tab over here in ML Studio. You can sort of see those jobs running. Ours should be completed though, because remember we started off like I kind of skipped through. So hopefully our cake is done baking, and you can see here the results of one of those runs. So if I select this was the one we just did. You'll see that over time, more and more steps, which means that the training is performed, which is we're showing it image data that it's training on, telling it where the objects of interest are, and then showing it images that it's never seen. You'll see that over time, as it does that more and more and more, the precision jumps all the way to an accuracy of, where are we, like 94%? Just in that simple training task. So behind the scenes using AutoML, it's going to allow us to find that best model. And we're going to be able to pull that out and see that working in just a few moments. So exciting stuff. You've seen just how easy this is to do. We're going to continue on. After we've executed that training step, we're going to run a command here that pulls the best child. So again, like I was mentioning with AutoML, there is this ability to look at best child run, which says out of all of the experiments that I've run, I want to choose the set of hyperparameters that led to the highest accuracy. We'll perform that in this cell here. That should give us the best model. And then from there, we're going to pull the Onyx file that was created and drop that into a models folder. So after you've executed cell 16, if we head back to our workspace, you'll see there's now a model folder. And inside of here is our labels, which are the objects that this model can detect, followed by the actual Onyx model itself that we can reference in the Onyx runtime. So now that we have this, it's definitely time to put it to work. So let's go ahead and do exactly that. Now, we're going to use the model we just created, but I do want to point out here we have an optional sample that we show here in the code where if you want to look at a historic run, you could actually go into like perhaps a previous run, which I'll show here, and you can choose here the name. And these names will always be given something that's like prefaced with a random GUID. If you copy that name and provide that as a parameter in this block, you can then perform the ability to extract the labels and Onyx file for that historic run. So great for demo purposes, or it's another way not to wait 7 minutes for folks that might be demoing this at a user group or other. Once we've got this model, though, we've already pulled it down. We've put it in our current working directory. This is the fun part. And Cassie, this is the time to shine, right? We're going to be using the Onyx runtime here, which is, as you're going to see, is super easy to work with this. So Cassie's going to tell us a little bit more about what we're doing here and show you just how easy it is. Once you've got the file in Onyx format, you're ready to go to the races and start detecting objects and images.
Yeah, and so another thing to note too is that we're using a cloud notebook, but like if you had this locally, you could also be running this on a local notebook and then running your experiments in the cloud too. So I just want to make sure that people understand, like even though we're using the cloud notebook and leveraging the cloud compute, we could also be doing this locally. And then same with Onyx Runtime here. So we are using the Onyx Runtime package, which I told you earlier is that open source package. And here to create an inference session, we just have to send in the model and the model path, and then it's going to run the session and we're going to get our results. So it's really super easy. You can get an inference in about 3 lines of code, and it's actually really consistent across the different languages that it supports as well. So if you're using C#, JavaScript, Python, whatever language you're using to do your Onyx Runtime inferencing, the way that you do it is actually the same, which is pretty nice.
That's amazing. And so we're going to then go through here. We're going to perform a few transformations here. So we're going to actually load in the inputs and outputs. So those of you who are familiar with CNNs or convolutional neural networks, this is showing the input resolution that would be expected for any images that would be sent to it for processing. And then the output types, which correspond to the classifiers. In our case, we have one for Diet Coke, Coke, and Sprite. Those are the output types that would be triggered to tell it what it's actually seeing. So all we have to do now, we want to actually use this model. We're going to pre-process our image. So remember, we did upload a test image. We're going to look at those expected heights and width, convert that image that's in testimage1.jpg, and we're then going to run the Onyx prediction using the get prediction from Onyx method here, and from that print out the result. Now, this won't make much sense because this is like this is purely running this against that format. We're now going to do some things where we're going to pre-process that to be able to show bounding boxes and labels on top of that, and finally add those in such a way that our result becomes human readable. So you'll see here, after we execute this line of code, you can see where it's finding things in that test image, which is interesting because I'll spoil the surprise. It's an image of all Cokes, and you'll see it sees a Coke, it sees another Coke, another Coke, another Coke, Coke, Coke. Basically, you can see all of the scores or the precision with which that it thinks that it's seeing that object. And finally, let's see literally what it sees. We're going to go ahead and run a little bit of MATLAB code here, and this will show all of the cokes that it's been seeing in the bounding box that detects where it thinks it's seeing those images in the image. So with just a few lines of code in Python, we're able to test the newly created model. And we've now created a full MLOps pipeline where we start from secure, structured data, unlabeled. We're able to label it, bring it in, train the model, and get the result. And that is absolutely fantastic. So with just 5 minutes left, we're going to quickly cover the knowledge check and then show you everything that you can do to continue on with this Learn module, because it's not over. There's actually a whole nother session to follow through. So real quick, the Azure ML SDK allowed us to connect and interact with our Azure Machine Learning Studio by providing a config JSON file that specified the details to connect, providing a connection string, or using our Azure credential strings, which are passed in transparently. In the instance of time and obviousness, I'm going to choose answer number 1. We use that config.json, and that got us to the races. Question number 2, the Azure ML Python SDK allowed us to provision a compute instance in our AML workspace that could then be referenced in Python code to submit AutoML tasks to run on the machine as a target. True or false? That one is, of course, true. We did do our training on that compute instance by supplying the name of the compute instance we created earlier. And finally, Azure AutoML allows you to tune hyperparameters to auto-discover optimal settings for your model. That is literally what it does. So we're going to go ahead and choose true. So we did fly through that one, but the reason why is I don't want you all to miss the fact that there is more to this learning path. So while we've gone through the middle sections here, there is an additional portion here where we take that Onyx model that we've created and we deploy that to something called NVIDIA Triton Inference Server, which is awesome. This is one of those like services that runs in the cloud. You can access it using shared memory or HTTPS REST calls to call from a library of Onyx models that might be loaded to it and get those results. And the best part is Cassie has already created the video that we didn't have time to show you today, walking you through this. And you can check that out at aka.ms/deploy Onyx. And Cassie, I'll let you plug that for just a moment here, because I know that that was one of the really cool sessions that you sort of end up with at the end of this module.
Yeah, so the Onyx Runtime channel has all kinds of content around how to use Onyx Runtime, and we created a video based on this last one on how to use the Triton Inference Server. So it shows you how to go through and use an Azure VM and get that configured. So check it out. It goes through it in 5 minutes and can hopefully kind of guide you through the process of that module.
So definitely check that out. It's super awesome, and we'll get you using that model essentially in a production type of use case. And finally, at the end of this, since some of this is built, of course, on NVIDIA technology working together with Microsoft Azure, we would love to point you over to some great resources from NVIDIA. That includes the NVIDIA Developer Program, which you can find in the QR code at the bottom left, and also the NVIDIA Deep Learning Institute, where you can take interactive courses that leverage NVIDIA technologies using, in some cases, machines that are hosted in Microsoft Azure to perform various different tasks using NVIDIA hardware. So with all that mentioned, the last thing everybody needs to know is you've either completed all of this module or you're getting ready to do it. But definitely, if you enjoyed this today, be sure to check out the module that we've been following along at aka.ms/learn-automl. And that'll show you everything that we've covered today, in addition to giving you that ability to follow this along, share it with others, use it in course content. However you want to use this, it's all available here at aka.ms/learn-automl. And with that said, we're happy that we were able to make it through here. We're now unfortunately going to have to wish everybody a farewell for this particular session. So it's been a pleasure. Cassie and I have super enjoyed this, working with everyone today. And Cassie, is there any last words that you have that you'd love to tell the audience while we're signing off today?
No, I just want to say thanks for hanging out. If you build something cool, definitely tweet about it and tell us about it, because we'd love to see your custom use cases. So yeah, let us know what you're building. We're on Twitter. Follow us at the follow tags you see on screen. And we hope you enjoy the rest of Microsoft Build 2022. Thank you, everyone, and cheers. Thanks.